Good morning, grade 10s. This is Mrs. Buerta speaking. I hope that you guys are well and that you're keeping safe and keeping healthy, and I hope that we will be able to see each other soon. Today we are going to carry on with Euclidean Geometry, but before we get started with today's work, we are just going to do a quick recap. If at any point you want to pause the video to make notes in your book, please do so, and please don't forget to write today's date and heading. The first thing that we are going to quickly revise is our conditions for congruency. Now please remember that congruency means that you have two identical triangles. They are the same shape, they are the same size, all three lines are identical, and all three angles are identical. So our four conditions for congruency, the first one is side, 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 meaning that all three sides of both triangles are identical. The second would be side, included angle, side. The third is side, angle, angle. And the fourth one would be right angle, hypotenuse, and side. And obviously the fourth condition would be only if it is a right angle triangle. The next thing that we are going to revise is the properties of a parallelogram. The first one is that both pairs of opposite sides are equal. The second is that both pairs of opposite sides are parallel. The third is that both pairs of opposite angles are equal. And the last one is that the diagonals bisect each other. The last thing that we're going to quickly recap is what we did yesterday. So if you are given a quadrilateral, if they tell you it's a quad and they ask you to prove that it is a parallelogram, there are 5 ways of doing it. The first is to prove that both pairs of opposite sides are parallel. The second is to prove that both pairs of opposite sides are equal in length. The third is to prove that both pairs of opposite angles are equal. The fourth is to prove that the diagonals bisect each other. And the last would be to prove that one pair of opposite sides are both equal and parallel. And if you can prove one of those 5 things, then you are proving that a quadrilateral is a parallelogram. We're going to start off with today's work then. We are going to start by doing Theorem 1, which you can find in your textbook on page 190. So in this theorem, they are going to ask you to prove that the opposite sides and angles of a parallelogram are equal. So one thing you need to note is that it will be given that you have got a parallelogram. So they will say to you, A, B, C, D is a parallelogram. And then what you need to be thinking is when they say to you it is a parallelogram, you should already start thinking of your properties of a parallelogram, and they should come to mind. So you should already start thinking, because it's a parallelogram, I know the opposite sides are equal. Because it's a parallelogram, I know the opposite angles are equal. Because it's a parallelogram, I know the opposite sides are parallel. Because it's a parallelogram, I know the diagonals bisect each other. So those should be coming back to you. Okay, so this theorem that we're going to do, Theorem 1, you are going to have to memorize it. You're going to have to study it. They will sometimes ask you to state Theorem 1, and you would then need to actually memorize it and show us how we prove that the opposite sides and angles of a parallelogram are equal. As you can see, it says parallelogram ABCD, where AB is parallel to DC and AD is parallel to BC. So basically what it's saying is that the top line and the bottom line are parallel to each other, and that the two side lines are parallel to each other. And then they are asking you to prove that AB is equal to DC, so equal in length. They're asking you to prove that AD is equal to BC, and they're asking you to prove that angle A is equal to angle C, and that angle B is equal to angle D. So we're going to start with the proof now, and this is the part that you will need to memorize and that you will need to be able to write down in an exam. So the first thing that we've done is we've constructed line AC. You can see it's a diagonal there in your parallelogram. And What I want you to be thinking is, if you look at your parallelogram, you can see it's now been split into two triangles. So we are trying to prove that AD, the top line, and BC, the bottom line, are equal in length. We're also trying to prove that AB, the side, and CD, the other side, are equal in length. So in essence, what we're actually trying to do is prove that those two triangles are identical. In other words, congruent. So what we're going to do is we are going to try and prove that those two triangles are congruent. If they are congruent, it means that they're identical, and obviously then the opposite sides would be equal and the opposite angles would be equal, which is what we are trying to prove. So if you have a look at your statement and reason there, you can see in triangle ABC and in triangle CDA, the first thing, the easiest thing to spot is that your diagonal AC is a common side. So we have a side. The second thing that you can see is that angle A2 and angle C1 form the shape of a Z or an N, so that should make you think of alternate angles. You can see that line AB is parallel to CD, so angle A2 and C1 are alternate angles, so we have a angle which is the same for both of them. The third thing that you can identify is that angle A1 is equal to angle C2. You've got parallel lines cut by transversal, so we have another set of alternate angles which are equal. So therefore we have three reasons. We have a common side and we have two angles, so we can prove that triangle ABC is congruent to triangle CDA, and our reason would be side angle angle. Now because our two triangles are congruent, in other words identical, it means that all three sides of the one triangle are equal to all three sides of the other triangle. It means that all three angles of the one triangle are equal to all three angles of the other triangle. So therefore, side AD is equal to side BC, side AB is equal to side CD. Also, angle B is equal to angle D, and angle A is equal to angle C. So therefore, we have now proven that this parallelogram has got opposite sides which are equal and opposite angles which are equal. So what we've done is we have constructed a diagonal, we have proven congruency, which means that our opposite sides are equal and our opposite angles are also equal. The next thing that we are going to learn is the converse of Theorem 1. So we use this when they give us a quadrilateral and they ask us to prove that the quadrilateral is a parallelogram. So for example, they would say to you that ABCD is a quadrilateral. They would give you some information about the quadrilateral, and then they would say to you, prove that ABCD is a parallelogram. And there are two ways that we can do this. The first is if the opposite sides of a quadrilateral are equal, then the quadrilateral is a parallelogram. So you should already know a property of a parallelogram is that the opposite sides are equal. And the second is if the opposite angles of a quadrilateral are equal, then the quadrilateral is a parallelogram. And once again, you should know that a parallelogram has got opposite angles which are equal. So I'm actually going to do this example with you guys now, and then I'm going to do another example with you from your homework just to get you started. Okay, grade 10s, we're going to do the first example together. So there is a picture of it. It says trapezium ABCD, and they've given you some information about the trapezium, and they've then asked you to prove that ABCE is a parallelogram. And I'm going to move over to a video to do this with you. Okay, so grade 10s, they tell us that ABCD is a trapezium. They tell us that EC and DC are equal in length, making this an isosceles triangle. They also tell us that angle A is equal to 70 and angle D is equal to 70, and what they want us to prove is that A, B, C, E is a parallelogram. Now we revised the ways to prove that it is a parallelogram. The first one is that the opposite sides are equal in length. The second is that the opposite angles are equal. Now you can see that none of the lengths of the sides have been given, but we have an angle that has been given. So automatically you can see that we're going to be working with the angles, and we are going to try and prove that the opposite angles are equal in length in order to prove that this is a parallelogram. Okay, so we're going to start off. They tell us that EC is equal to CD. This is 70, which you already should be able to see that this over here is equal to 70 degrees. Okay, so we're going to write there that EC is equal to CD. Your reason, angles opposite equal sides. So it's basically because it is an isosceles triangle that is equal to 70 degrees. The next thing that you should be able to see is they've told you that AD is parallel to BC. So we have two parallel lines cut by a transversal. So what I'm going to do is I'm going to draw the shape that I'm working with, and you guys should all see that shape there, which is a Z or an N, which means that this angle there and that angle there are alternate angles, and we know that alternate angles are equal. So then you can say E2 is equal to C1, which is equal to, that we already know it's equal to 70 degrees. Your reason would be alternate angles are equal, but remember you have to state which lines are parallel, so you can say that AD is parallel to BC. Okay, so far we have worked out that this angle here now is 70 degrees. Okay, already you should be able to see that A and C1 are equal. Okay, so we can write that down, that A is equal to C1, which is equal to 70 degrees. Okay, but we need to prove that both pairs of angles are, that both pairs of angles are equal. I'm just going to zoom out a bit here so that you can see the whole screen. Okay, so I've proven those are equal. I need to now prove that B and E1 are equal as well. So the first thing that you can see, or should be able to see, is that E1 and E2 are adjacent supplementary. So that being the case, if E2 is 70, you can see that E1 is 110 degrees. So from there you can say that E1 is equal to 110 degrees. Your reason would be adjacent supplementary, adjacent angles on a straight line. So angles on a straight line equals 180 degrees. And from there, we now want to work out angle B. So you should see again that you've got parallel lines cut by a transversal, excuse my skew line, and you should see that this forms the shape of a U. So we know that A and B are supplementary, means they add up to 180. So therefore, you can see that angle B is equal to 110 degrees. So what you would do is you would say angle A plus angle B is equal to 180 degrees. Your reason would be co-interior angles, and remember you have to state which lines are parallel. So you would say that AD is parallel to BC. From there, you would then, we already know that A is 70, so 70 plus B equals 180. So therefore angle B is equal to 110 degrees. So we've worked out that angle B is equal to 110 degrees, and what you should see is that E1 and B are equal to each other. So we can then say, therefore, angle E1 is equal to angle B, which is equal to 110 degrees. And now what we've done is we've proven that both pairs of opposite angles are equal. So therefore, ABCE is a parallelogram, and our reason would be opposite angles are equal. Is that working out there? So you can see ABCE is a parallelogram, and your reason opposite angles are equal. Okay, grade 10, so we're moving on to our second example. You will find this in your textbook on page 193. It's actually one of your homework questions that I'm going to do with you. And you will see that they tell you that you are dealing with a quadrilateral. They give you some information about the quadrilateral, and then there's a couple of things that they want to prove. So I'm going to switch over to a video now, and I'm going to do this example with you. Okay, grade 10, so we are going to do example 2 now. So page 193, question 11 in your textbook. And the first thing they say is that quadrilateral LMNP, they tell us that E1 is equal to 62 degrees. So I'm going to fill in that 62 degrees there. They tell us that angle P1 is 68 degrees. So I'm going to fill in that 68 degrees there. They also tell us that angle P2 is 56 degrees, so I'm going to fill in the 56 degrees there. Then they tell us that FP is equal to FN, so you should see that that is an isosceles triangle. And they also tell us that LE is equal to LM, so another isosceles triangle. So the first thing that they've asked us to prove is that LP is parallel to LM. LP is parallel to MN. So that's the first thing that we're going to prove. Don't forget your statement and reason. So we're going to start off with number A, trying to prove that these are parallel. So the first thing I'm going to do is, you can see in this isosceles triangle, if that angle is 56, then this angle should also be 56. So I'm going to say that angle N is equal to angle P2, which is equal to 56 degrees. My reason, angles opposite equal sides. And it's basically an isosceles triangle. And I'm going to fill in that 56 there. Then what you can see is in this triangle, you have got an unknown value, which is P2. So you would know that the interior angles of a triangle is equal to 180. So to work out F2, I'm going to say F2 is equal to 180 minus 56 minus 56. So I'm saying this angle is equal to 180 minus the other two angles, and I get angle F2 is equal to 68 degrees. My reason, interior angles of a triangle are equal to 180 degrees. Okay, so I'm going to fill in my 68 degrees there. Right, so something that you should notice now is that in this diagram, those two angles are equal to 68. Now if I had to draw a little shape there, you would see that it forms the N or the Z, which we know are alternate angles. But in grade 8 you would have learned that alternate angles are only equal if the lines are parallel. So because these are both equal to 68, they are in the position of alternate angles, but we know that alternate angles are only equal if our lines are parallel. So then what you would do there is you would say, therefore, angle F2 over here is equal to angle P1, which is equal to 68 degrees. And you can see, like I showed you, they form your alternate angles. So therefore, you would say that LP is parallel to MN, and you can just say there that it's alternate angles, which means that it's parallel lines. Okay, so because these two are equal to each other, they form the position of alternate angles, and we know that alternate angles only work when we have parallel lines. So therefore we have proven that LP is parallel to MN. Moving on to question B. Question B, they've asked us to prove that LPMN is a parallelogram. So once again, there's two ways of doing it. You can prove the opposite sides are equal in length, or you can prove the opposite angles are equal. So we haven't been given any sides, so we're going to work with our angles. So the first thing that you should see is that in this triangle here, that is another isosceles triangle, so I'm working with number B, and you should see that M1 and E2 are equal because of the isosceles triangle. So you're going to say there that M1 is equal to 62 degrees, and your reason would be angles opposite equal sides, and I'm going to fill it in there, 62 degrees. And because of the two angles that are given, we can work out the third, interior angles of a triangle. So what you're going to do is you're going to say that angle L is equal to 180 minus 62 minus 62. So we get angle L is equal to 56 degrees. And your reason, interior angles of a triangle. Okay, so from there, I'm going to have to move it up a bit. You should already see, if this angle here is 56 degrees, you should already see that angle L and angle N are equal to each other. So you can say there that angle L is equal to angle N, which is equal to 56 degrees. Okay. Now we've proven that one pair of opposite sides are equal, one pair of opposite angles are equal. Now we need to work on these here. So I'm running out of space a bit, but what I'm going to do is that we've already proven that these lines are parallel. Okay, so those lines there are already parallel. Now what can you tell me about this shape there? Can you see that it is alternate angles, which means that this angle is equal to that angle there. Okay, so from there we can prove that angle M2 is equal to E1, which is equal to 62 degrees. My reason, alternate angles are equal. Don't forget to indicate which parallel lines, and we've got LP parallel to MN. So back to my drawing, you can see there that now this is 62 degrees. So we have the values for M, angle M, which is 62 and 62, and angle P, which is 68 and 56. And now it's just a matter of calculating each of those corners, and hopefully we will prove that they are equal. So I'm going to start with angle M is equal to 62 degrees plus 62 degrees, which gives me 124 degrees. And then I'm going to start with angle P is equal to 68 degrees plus 56 degrees, which also gives me 124 degrees. Okay, and from there we can then say that angle M is equal to angle P, and I'm running out of space here, but you would go on to the next page. Therefore, LMNP is a parallelogram, and your reason would be opposite angles are equal. So you can see here we've proven that L and N are both 56 degrees, and we've proven that M and P are both 124 degrees. which means our opposite sides are equal. Our opposite angles are equal, which means it is a parallelogram. Alright, grade 10s, that brings us to the end of Theorem 1 and its converse. For homework, you need to please do question 10 and 12 in your Mind Action Series textbook on page 193. And after this video, you're going to have a bit of time with your teacher. If there's anything you don't understand, please ask him or her. And when you start with the 2 questions, homework questions, if there's anything you're stuck with, please ask your teachers. That's what we're here for. Have a lovely afternoon and stay safe.